Hi, welcome to lecture number 1 in 4G mobile communication. My name is Kumbesan Sandrasegaran, and I'm going to give you this lecture. So what are we going to look at in this first lecture? Okay, so in the first lecture, we are going to have a look at why there was a need for 4G LTE. What were some of the important things that were taking place in the broadband market, that led to the development of 4G. And also 4G was developed because there were limitations in 3G mobile networks. And the next thing we'll also look at is what are some of the important requirements of 4G that were specified during the standardization process. The second thing that we're going to look at is the standardization of 4G LTE. It was essentially standardized by an organization called 3GPP. So what is the 3GPP? And the 3GPP has many releases, so we're going to have a look at some of these releases. We're going to also look at some important differentiators of 4G and also some aspects of 4G markets, as well as services and applications that run in a 4G mobile network. So the first question we're going to try and answer is, why was there a need for a 4G LTE network? Well, over the past 10 years or so, there has been an explosion in mobile data traffic, as shown on the graph here. Okay, so essentially, ever since the introduction of 3G mobile networks in the form of CDMA 2000 and wideband CDMA, which is around 2000, and as the need for data started to grow rapidly once consumers started seeing the benefits of mobile data, and it has continued to increase. So at present we have about 6 billion mobile subscribers throughout the world, and it will continue to rise. So in terms of markets, as I said, the mobile phone population is increasing rapidly. A lot of the applications that were built for the fixed broadband, such as YouTube and Google and so forth, can all be exported to the mobile environment. So you now see more and more people using YouTube on the mobile network. Now, when we talk about mobile devices, we're not just referring to mobile phones only. There's a whole bunch of other devices. We are looking at PDAs, laptops, USB devices, all of which can be connected to a 4G mobile network. Just to recap a little bit about the evolution of mobile networks, the first generation mobile networks came out in the 80s. They were predominantly analog mobile communication systems, and examples of this were NMT, AMPS, and so forth. 10 years later, we had the second generation mobile communication systems, which were digital. Examples of second generations were GSM, CDMA1, and so forth. And 10 years later, around 2000, the third generation mobile communication came about, and there was an IMT-2000 proposal or framework that was drawn up by the ITUR, and a number of 3G mobile communication standards came out of that, mainly UMTS, CDMA 2000, and so forth. And so you can see that every 10 years there has been a new mobile generation, and in around 2000 the 4G mobile revolution started, and again it was based on the IMT-Advanced framework that was defined by the ITUR, and the most important standards that are coming out of this are the IMT-Advanced as well as the WIMAX. And 10 years later, so by 2020, the 5G standard will be out, and in this one it's not yet well defined what it's going to be, but it's going to carry a lot of aspects of the LTE advanced network. So in order to explain to a layperson what is what are the differences between 2G, 3G and 4G mobile networks, let's take an example. So let's take the example of downloading a map, a 50 kilobyte map from the internet. And if you were to use GSM, it would take 42 seconds, 6 seconds on a GPRS network, 1 second on an edge network, and 0.2 of a second on a UMTS network, and even much shorter on a LTE network. Similarly, if you look at a larger Word document, a 50 kilobyte Word document, it would take 7 minutes on a GSM network, 1 minute on a GPRS network, 10 seconds on an edge network, or 2 seconds on a UMTS network, and less than a second on a 4G network. If you're looking at a soundtrack, so you want to download a Beatles track, it could take 34 minutes on a GSM network, 5 minutes on a GPRS network, 1 minute on edge, 10 seconds on a UMTS network. And some of the services which we can now watch on a 4G mobile network and a 3G mobile network, such as audio and video streaming, could not have been possible in earlier 2G networks. One of the things I said earlier is we're going to discuss the limitations of a limitation of a 3G network, and we see how the 4G LTE network has overcome this limitation. So the first thing is in terms of data rates. So the composite data rate in a 3G network is 14.4 megabits per second on the downlink side, and on the uplink 5.7 megabits per second. So this is using HSDPA and HSUPA. With the LTE standards and using 20 megahertz of spectrum, we can get a composite data rate of 100 megabits per second in downlink. So that's almost 5 to 6 times what we can achieve with the 3G network. On the uplink, we can achieve a data of about 50 megabits per second. Another problem that we had with 3G network is that every operator needed a minimum of 5 megahertz spectrum to launch a 3G network. Okay, and if you're using FDD, frequency division duplexing, you would need 5 megahertz for uplink and 5 megahertz for downlink. So this is pretty expensive in the early days of 3G launch. So in LTE, they decided the possibility of having spectrum that is variable. So it could run on a 1.4 megahertz network, a 3 megahertz network, a 5 megahertz network, 10 megahertz, 15 megahertz, and 20 megahertz. So all these are possible bandwidth on which an LTE network can operate. So a new startup operator could launch an LTE network using 1.4 megahertz of spectrum, and a well-established LTE network could be run using a 20 megahertz spectrum. Now, the other problem that we also have is a 3G network. Because of the fact that it is CDMA, you can see that every user is transmitting on the entire 5 megahertz spectrum at the same time across the entire 5 megahertz spectrum. So if there is something called frequency selective fading, that means one portion of the frequency band gets faded due to a number of effects in the environment, the entire signal gets destroyed in the process. So it's highly sensitive to frequency selective fading. Now 4G LTE has overcome this problem, and later on when we look at the air interface of the LTE network, we will see how this problem has been solved. Okay, so if you look at the requirements of the LTE network, in terms of spectral efficiency, it's got 3 to 4 times that of release 6 HSDPA, and on the uplink it is supposed to achieve an efficiency of 2 to 3 times that of release 6 HSUPA. It's got scalable bandwidth, so it can operate on 1.4, 3, 5, 10, 15, 20 megahertz spectrum, and it can also operate in many parts of the spectrum. Okay, so from all the way from 450 megahertz to 2.6 gigahertz bands. In all these bands, and we also saw the peak data rates, about 100 megabits per second for 20 megahertz spectrum and around 50 megabits per second for 20 megahertz spectrum. Another important aspect is latency or delay. So in the control plane, LTE is supposed to have a C plane, which is a control plane. It's supposed to have a delay less than 100 milliseconds to establish a call in the U plane, and U plane refers to user data that's flowing, so that should have a delay less than 10 milliseconds. So C plane is essentially all the signaling that needs to take place for a call to be established. And there are some other requirements related to mobility. So it's supposed to work all the way up to speeds of 350 to 500 kilometers per hour. Obviously, the faster you're going, the more the degradation of signal quality. And the last aspect related to mobility is handover. So as users are moving around, handover is taking place constantly. So the time taken for the a new connection to be established for real time and non-real time have to be less than 300 milliseconds and less than 500 milliseconds respectively. Okay, so we've talked about why the 4G network is beneficial for the user, but it's also quite beneficial for an operator, even though an operator might have to invest millions of dollars rolling out an LTE network. So first, because of the fact that it uses OFDM and MIMO, it means that the performance, the spectral efficiency is going to be much better on a 4G network compared to a 3G network. And also because of the fact that you have flexible use of spectrum is also beneficial for an operator. The other aspect of a 4G network is that it's an all IP network. So from the time packet is generated in the mobile phone till it reaches the server or another mobile phone, everything is in the form of an IP packet. And so 4G does have a lot of advantages for an operator. You can see that we saw that it can have higher data rates and lower latencies, and all of the LTE standards are all open standards, so everything is openly defined and anybody has access to the standards. Okay, just a recap. This is just some of the important features of an LTE. Most of this I've mentioned earlier. LTE, which stands for long-term evolution, is based on a different radio access technology compared to UMTS. So we moved from CDMA based technologies to wideband to OFDMA based technologies because OFDMA performs better. But LTE network is still compatible and has to interwork with a UMTS network. An LTE network has high spectral efficiency both in the uplink as well as the downlink. It has very low latency for setup, that's both in the control plane as well as in the user plane, and also a low latency for handovers. It supports variable bandwidth from 1.4 to 20 megahertz spectrum, And the protocol architecture is much more simpler because it's based on packet switching only. And because of that change in protocol architecture, we also have a simpler architecture, because previously in the 3G network, which the radio access network was referred to as UTRAN, UMTS terrestrial radio access network, and now the radio access network in a 4G network is referred to as EU-TRAN or Evolve U-TRAN. And you can, as you see in the diagram on the bottom right corner, you can see that there's only one network element in the EU-TRAN network, which is the eNode B, or the evolved node B. And there are interfaces between base stations, which are referred to as the X2 interfaces. The LTE network can also operate an FDD as well as an TDD mode. So these are some of the important advantages of LTE Release 8. Okay, a quick quiz question for you. So spend a few minutes answering that, and then we move on. So the next thing that we are going to look at is the standardization of 4G. When you go back to mobile telecommunication standards, one of the first organizations that was formed was referred to as ETSI, or European Telecommunication Standards Institute. It was primarily brought about in the late 80s, primarily because each one of the countries in Europe had different mobile telecommunication standards, and as a result, when people moved from one European country to another, they could not use their mobile phone in the new country. So the ETSI was formed to develop a single standard for the whole of Europe, and this is how the GSM standard came out of that process. And since then, ETSI has developed many other standards. Now, the ETSI subsequently became part of the 3GPP. So the 3GPP is the body that came up with the 3G standards and also most of the 4G standards. Okay, so 3GPP stands for Third Generation Partnership Project. It was created in 1998, and a few years later they launched the 3G standards. A number of operators throughout the world are involved in that, and a number of standardization bodies also. So as far as the 3GPP body is concerned, they came up with, you can say that they were involved in the 2G radio standards, GSM, GPRS, X. They were involved in the 3G radio standards, WCDMA, HSPA, and the 4G radio standards, LTE and IMT-Advanced. They were also involved in the core network of the mobile network, the 3GPP core network. So they were involved in the 2G, 3G. They were also involved in the evolved packet core network of the 4G network. So again, a little bit more about the evolution. This diagram is a good diagram in that it shows the three important tracks. So you can see the first track, which is over here, represents the 3GPP track, which most of Europe and Australia have followed. So it went from GSM, 2G, 2.5G GPRS, wideband CDMA, HSDPA, HSUPA, HSPA Plus, and now LTE and LTE Advanced after that. And the data rates are shown here. You can see data rates have been increasing both in the downlink direction as well as uplink direction. There's also another track which is referred to as 3GPP2, and these were based primarily on the CDMA 2000 flavors, and there are some countries that follow this particular track. And then there's the IEEE track, which is based on WiMAX, and So it went from fixed WiMAX 802.16e 802.16m, the mobile WiMAX version. Okay, so we are more interested in the 3GPP track, and in the 3GPP track we can see that we moved from release 99 to release 4 to release 5, and now the LTE track is the release 8 track, and the IMT-Advanced track is the release 10 track. So these two words, release 8 and release 10, are probably the most important ones right now, and this also shows an idea of timelines as well. Okay, a little bit more detailed about the releases. Okay, after our release 10, we have further enhancements coming along the way, and this particular slide is from the 3GPP body. So as I mentioned in some of the previous slides, I said release 8 was the first LTE release, and release 10 is going to be referred to as the IMT-Advanced. So these are the two important ones that you need to remember. Okay, a quick question here about the organization that developed the standards for LTE. Okay, we move on. The next thing, the third topic in the first lecture, is looking at what are the important differentiators of 4G technology compared to the previous mobile generations. So we can see that in 2G and 3G mobile traffic, we had two types of traffic. We had voice traffic, which was predominantly circuit switched in the form of PCM time slots, and we had data traffic, which was packet switched, and both were coming separately into the BTS, or the base station, and the base station's task was to transmit the data to the BSC in a 2G network and to the RNC in a 3G network. And this node here separated the circuit switch traffic and the packet switch traffic. The circuit switch traffic was sent to the MSC, which processes all circuit switch traffic in 2G and 3G networks, and the packet switch traffic was sent towards the packet switch network, and we had the PDSN, which was mostly an SGSN that was responsible for handling packet switch traffic. Now the change in the LTE network is that both voice and data are going to be transmitted over IP networks. Okay, so end to end, so from the time information is generated at the source, it's converted into an IP packet and transmitted over an IP channel to the E node B, and it goes as an IP packet throughout from source to the destination will be an IP packet. So all of these are, you can see the word new at the bottom of the picture. So the interface is new, the base station E node B is new base station, the evolved packet core, all the network elements are completely different to the previous 2G, 3G network elements. So the key LTE features to overcome challenges. Okay, so as I mentioned earlier, OFDM has been introduced in 4G because it is a robust modulation and multi-access scheme, especially in dense environments where fading is more likely to occur, and you also have increased spectral efficiency from the use of OFDM. The next technology that forms part of LTE is the MIMO technology, multiple input, multiple output, both in the uplink as well as the downlink, and this can overcome multipath interference and increase the link capacity. The third important feature is the flat scalable IP structure. So we have something called a TTI, and we're using a very short TTI of 1 milliseconds compared to 2 milliseconds in HSPA and 10 milliseconds in wideband CDMA. So because of the reduction in the TTI, it can provide a lower latency. Yes, and the last thing is the flexible spectrum options, which are shown on the bottom. So we move to the part 4 of this lecture, and we're going to have a look at the 4G market. This diagram is a little bit dated. It's all the way back from October 2012. And you can see in red the countries with a commercial LTE service, and the ones in dark blue are the ones where LTE networks were being deployed, and it's now changed quite a bit. If you look at the map now, you probably have far more red than the situation in 2012. And on the next slide, listed some of the important operators throughout the world who were running a 4G network. Okay, and so the number of LTE subscribers is growing rapidly. In quarter 2 of 2012, there was 9.9 million LTE subscribers, and it's expected to grow further in the future. So one of the reasons for the success of LTE is that all of the operators and all of the vendors are all involved in the standardization process, and both the CDMA operators in Asia and the USA, as well as the UMTS operators, have started to work together for the first time. Remember, when you looked at the 3G situation, we had the 3GPP track as well as the 3GPP2 track, and so the standards they developed were two separate standards. That is, now they have realized the importance of cooperating together to get an LTE version out. So in LTE, there's two versions. There's the FDD version of LTE and the TDD version of LTE, and it's also possible for GSM countries that were staying on a 2G network to go directly to LTE rather than investing in a UMTS network. So that means some of the smaller countries where GSM is still running quite well, operators are there in those countries can go directly to LTE without going through the 3G step. As far as Australia is concerned, the Telstra and Optus were the first to launch FTD based LTE networks on the 1800 megahertz band. The NBN is also going to use TD-LTE on the 2.3 gigahertz band, primarily for supplying telecommunication services to rural areas, because the NBN will use fiber optics for urban areas. When they first launched the service in 2012, Optus had coverage in the 4 main cities, Sydney, Perth, Melbourne, Newcastle, and subsequently they rolled it out to all over the country. So this diagram showed how the Optus coverage looked like in the year 2012. You can see initially it was a hotspot technology, mostly in areas where there was a very high population density. And once Optus was convinced that the LTE network was working well, then they started rolling it out to the rest of the country. As far as LTE devices are concerned, LTE can be part of many types of devices, modules, plug-in modules, tablets. They can be part of a notebook. They can be a PC card, which can be part of a PC. You also have LTE in femtocells, smartphones, and routers as well. So a whole bunch of devices. You can see that majority of LTE user devices are what is referred to as personal hotspots. So somebody who does not want to pay for a cable internet might get a router which has a LTE card in it, through which it can communicate directly with an LTE network. So here are some examples of LTE capable devices. I think you are aware of most of these devices, so I do not need to waste any time on them. Okay, in terms of services and applications, primarily we can divide services, whether it be on a 3G network or a 4G network. Services can be classified into person-to-person services, and within person-to-person services you can have person-to-person circuit switch services and person-to-person packet switch services. And then the second category is content-to-person services. Fourth category is business connectivity, and the fifth category is location-based services. So examples of each one are given. So person-to-person circuit switch would be things like voice communication, a video communication between two people. When we talk about person-to-person packet switch service, things like VoIP, email would classify under that. And content-to-person services, when you're doing audio streaming, video streaming, or internet browsing, these are all content-to-person services. And business connectivity is primarily connecting between a mobile subscriber and a corporate intranet. And location-based services, there are many examples of this, but assisted GPS is probably one of the important ones in location-based services. Okay, so another area that is becoming very popular increasingly is the area of M2M, which stands for machine-to-machine communication. So this could be used for things like meter reading and communication, telemetry purposes, and so forth. Okay, so on the next diagram we have we can see how the 4G mobile network is going to have an impact on some of the applications. So you can see that some of the existing applications worked quite well on a 3G network, so 4G has limited impact on them. Okay, things like MMS, for example, will run perfectly well on a 3G network. There are some services here that are enhanced by a 4G network, things like HD voice, smart home monitoring, and so forth. And there are other services which are going to be enabled by 4G. That means they were not possible previously on a 3G network. Examples being HDTV and so forth. So I'm going to end session 1 with a set of review questions which I'm expecting you to go through, because these are the ones that would be testing you in exams. So that's the end of session 1, and there are some slides that have been placed in the slide pack, so you can have a look at them, but they're not examinable.